So one of the biggest things we got to make sure we do is plot these points correctly. I did this one already once, and of course plotted the points incorrectly. So now I'm doing it again. So don't be like me. Negative 1, 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 1, 2. So then that's P, A, and T. P, A, and T. All right, so this is a longer proof. They don't usually ask them that are this long. This is a fairly old one, but it has basically just two different proofs included in it. So I have a triangle there, and it says, prove that it's an isosceles triangle. You got to really read this because it has a few different things here. They weren't all together like this. They were spread out, but I put them on the top of the page. So prove it's an isosceles triangle. So isosceles triangle, I'm going to come over here, AT, PT, PA. And I'm going to find the slope and distance. Slope, distance. All right, so let's go to my graph. And let's do this. Hopefully, since it's isosceles, and I hopefully graphed them right this time. Hopefully two of them will have to be the same. They didn't last time. 1, 2, 3 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up. 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. 1, 2, 3, 4, 5, 6, 7 down. 1, 2, 3, 4 down. 6 to the right. All right. None of those numbers are the same, but I'm hoping the Pythagorean theorem is going to give me a couple that are the same. But we'll find out here and see if we did it wrong a third time, or a second time, sorry. All right, so AT is down 7 over 9. PT is down 4, left 6, which is 4 over 6 because they're both negative. And then PA is up 11, left 3. All right, so then my distances are negative 7 squared plus 9 squared equals x squared. And that's negative 7 squared plus 9 squared, 130. So square root of 130. And then negative 4 squared plus negative 6 squared equals x squared. That should be square root of 52, but let's double check here. Negative 4 squared plus negative 6 squared, and that's not a 52. And then 11 squared negative 3 squared equals x squared. 11 squared plus negative 3 squared. 130. Beautiful. There we go. Worked this time. Square root of 130. All right. These two are equal. All right. So then I write down, we're going to put it over here based on my calculations. This is an isosceles triangle because it has two equal sides. Okay. Taken care of. Then it says find the coordinate of R, so that PART is a parallelogram. Now you gotta be careful. It should be up here. PART should go that direction. All right, and I'm just gonna take this slope right here. I'm gonna go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's point R, and it is at 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's that part taken care of. Then it says prove it's a parallelogram. All right, so now here's the issue. I've got two new sides, so I'm going to do the parallelogram in green. All right, so I already have the information for PT and PA, but I do not have the information for AR, and I also don't have it for RT. All right, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to circle the ones for those two sides. So I'm starting to get a little bit of a disaster looking thing, a little bit of what my work always looks like. So then I have AR and I have RT. All right, and now AT is no longer part. I'm gonna just put like a little X by it. It's no longer part of the parallelogram. All right, so AR is up 4/6, and RT is down 11/3. And what I should notice here is I have parallel lines right there, and I have parallel lines right there. I can do the distances, but I don't need them. All right, so if I do the distances, that's fine, but I don't need them. And what I can say is based on my calculations, it is a parallelogram because it has two pair of parallel sides. Okay, so I got everything labeled there. That's a longer coordinate proof than you're more than likely going to see. That's an old 6.1. They don't really do 6.1s very often anymore. It is possible, all right, but usually they're just 4 points or less than that. So it normally would either be just finding that it's a isosceles triangle or finding the point and saying it's a parallelogram. One of the two, not two at the same time.